The first FRQ on any AP Physics exam is called the mathematical routines. In this video, I'm going to show you exactly how to do it. There is a step-by-step process for the questions they give you. I'm going to show you the key skill that you need, as well as the difference between determine and derive. And the key thing that you need to do with a derive question is always begin with a fundamental formula. So they're going to ask you to write down something from the formula sheet, one of the basic principles. It could be Newton's second law, F equals ma. It could be torque equals distance times acceleration. So you always want to begin a derived formula by writing something down, which is a basic physics principle, and then working from there. Actually, you'll get 1 mark, 1 free mark, just by writing down that basic equation. So always start a derived question by writing down an equation. It's important to know this question will follow a pattern that will be the same every year. The pattern is this. There's an A part and a B part. In A part 1, you're going to need to use a representation like a free body diagram or a graph. They're going to give you a question and you need to draw something like that. In A part 2 and 3 and even 4, you're going to do mathematical representations like determining or deriving a formula. Then there's going to be a part B. In part B, there'll be a similar but slightly different question. And this time, we're going to have to use what's called qualitative reasoning using our words. So the skill of the mathematical representation is for part A, 2, 3, and sometimes part 4. Let's do a question and you'll see that journey. In experiment 1, students release a disk of mass m and radius r from rest to the top of a ramp that makes an angle with the horizontal. The disk rolls without slipping, as shown in figure 1. The rotational inertia of the disk is I equals 1/2 mr squared. The frictional force exerted on the disk is F. On the diagram in figure 2, label and draw arrows representing the forces that are exerted on the disk as it rolls down the ramp, which is indicated by the dashed line. Each force in your diagram must be represented by a distinct arrow starting on and pointing away from the point at which the force is exerted on the disk. So this is like a forces question with something sliding down a ramp, but there is a rotational component to this. So this is really to do with thinking about rotation and forces. We'll have to be thinking about energy as well a little bit, but rotation and forces is the key idea here. So if we think about this circle, there are 3 forces on it. So there's going to be the force of gravity going straight down. We should draw this coming from the center of the mass, just like with all our free body diagrams. And then we should have the force of normal, and that's going to be perpendicular to the surface, so at an angle. There's also the force of friction. Now, the force of friction doesn't come from the center. It's actually along the bottom. It's going to be parallel to the motion. Okay, so far so good. So the first part is actually drawing a free body diagram. Now, in the next part, we're going to begin the derivations or determinations. 2, determine an expression for the net torque exerted on the disk around the center in terms of theta, ff, m, r, and physical constants, as appropriate. In the FRQ, there are important keywords that are worth knowing about. First one is derive. Starting with a fundamental law or relationship, perform a series of mathematical steps to derive at a final answer. The other word that you need to know about for this question is determine. To make a decision or arrive at a conclusion after reasoning, observation, or applying mathematical routines. Both deriving and determining are going to ask you to write down some math or formula or equation. But the difference is, with determine, you can just write it down. Those questions are usually just worth 1 mark. With derive, what we're going to do is start with one physics principle and do some algebra and come up with an answer. These questions are usually worth more like 3 marks. So in this question, both the force of normal and the force of gravity create no torque. They're coming straight from the center. There's no hinging going on. However, the force of friction is like a torquing force, which is a radius away from the hinge. So that's going to create torque. So here's a mathematical expression. The net torque is going to be Fr times the radius. That's the distance. And that's it. So I just have some expression with variables. That's going to be for the torque. 3. Determine an expression for the net force exerted on the disk in terms of theta, FF, MR, and physical constants. So this is also determine. So this is going to be easier than the derive word. So if we look at the free body diagram, we can imagine the forces going perpendicular and parallel to the surface. And the perpendicular ones are balanced. There's no acceleration up or down. So there's just going to be a net force going parallel. So here I just say F net is going to be two forces minus from each other. And what are they? It's going to be the gravity force parallel minus the friction force. So we can leave FF as it is, but we just got to put some more variables in for the force of gravity. It's going to be mg times sine theta. Theta is going to be like that, so I need that component. When a question says determine, we actually just have to write something quite simple and get 1 mark for that. The next one has derive. So this is going to be a little bit more difficult and worth more marks. Derive an expression for the translational acceleration of the center of the mass of the disk. Express your answer in terms of m, theta, r, and physical constants as appropriate. Begin your derivation by writing a fundamental physics principle or an equation from the reference information. So the key equation that we need to write down for 1 mark might be Newton's second law. So let's write that down. So that's it. That's 1 mark already. We get a mark by just writing that down. So we already have an expression for F net from the last part, so let's write that down. mg sine theta minus FR equals ma. So the trick for this question is figuring out what is the force of friction. We normally, for like a block sliding, do something to do with the force of normal. Maybe force of friction is mg cosine theta. That's not correct here because the force of friction really is connected to the torque here. Now, they've been hinting at this for us because they put that there in question 2. We have an expression for the torque connected to the force of friction. So we're going to need to spend some time deriving a formula for the force of friction. So let's begin with the torque. This is what we wrote down before. Torque net is the force of friction times the radius. And we now need to cite Newton's second law in the rotational form. Torque net equals I, moment of inertia, times alpha, angular acceleration. Each of these 3 terms we need to think about carefully. The first one on the left, torque net, we have. That's the term here. The second one, the moment of inertia, they gave that to us in the question. They said, here's a disk that has a moment of inertia. I equals 1/2 mr squared. They're actually hinting at the answer for this question by telling us the moment of inertia, because we haven't used that yet. We don't always need to use everything they give us, but often we do. And we need to use the moment of inertia here in this question. Let me write that down. And finally, I need to have an expression for alpha. There's an equation that connects angular velocity to translational velocity. Omega equals v over r. And there's another one which is pretty much the same for acceleration. Alpha is a over r. So here we can change alpha in terms of acceleration and radius. Now we've got 3 pieces, 1 for torque, 1 for moment, 1 for alpha. And we're going to take those 3 pieces and plug them in. I'm going to use colors here. That's for torque, that's for moment, and 1 for alpha. All right, so we've got to plug all that in now. So we get FR times R equals 1/2 mr squared times A over R. I'll again color coordinate that. That's the moment, that's the alpha, and that's the torque. So now we can simplify this. We notice that there's a bunch of r's, and actually altogether all the r's are just going to cancel out. 1 here and 1 here. So we get an expression for the force of friction like this. Wow, quite interesting. So here I now have the force of friction, so I can take that and put that into my original Fnet formula up here. So let's do that. So I get mg sine theta minus 1/2 ma equals ma. So here's the force of gravity, and here's the force of friction pulling against it. And that's the real acceleration. So now I see this, and I can actually see that all the masses cancel. So I can just do that. And then I can move the 1/2 a to the other side. So I'm going to get 1a plus 1/2 a, so 3/2 or 1.5 a. And the last step is move that fraction over. Okay, now we have an expression for the acceleration. Acceleration equals 2/3 g sine theta, and it's equal to those terms. It's actually just g and theta in there. So that was quite a lot of steps. So the first mark we get by writing down the fundamental principle, F equals ma. We get the second mark once we get to alpha is a over r. We bring that concept in and we get this expression for the force of friction here. And the third mark comes when we get the right answer at the very end. So a derived question might be worth 3 marks and has these steps in it. And the goal is to get an expression like this one for something like acceleration. Okay, now we've done part A, we're going to move on to part B. In experiment 1, the disk reaches the bottom of the ramp in time t disk. The students release a block of ice from rest from the same height on the ramp, inclined at the same angle theta, as shown in figure 3. Friction between the block and the ramp is negligible. The block reaches the bottom of the ramp in time t block. Indicate whether t disk is greater than, less than, or equal to t block by writing one of the following. When they ask us to indicate, all we got to do is write it down. We don't need to add anything else. However, there's a bit more next. It says, justify your reasoning. In justification, include qualitative reasoning beyond mathematical derivations or expressions. Now, this is really important. When it says use qualitative descriptions, it means don't use math. Use words and arguments and ideas in English rather than mathematics. So how do we do this question? You can see in the diagrams, these are quite similar. One is a circle that's rolling down, and one is a block that's sliding down. Now the question is, which of these is going to have a smaller time, or which of these is going to go faster? There's 2 ways to think about this, and I'm going to use the way that thinks about energy. The correct answer is that t disk is larger than t block. And let me talk about why. If we think about energy, both these blocks start with potential energy. The disk has potential energy, which is going to be mgh, and the block has potential energy, which is also going to be mgh. And they both go down the hill. As the block goes down the hill, that potential energy is going to be converted into kinetic energy, in particular translational kinetic energy. And 100% of that is going to be translational kinetic energy. There's no friction. For the disk, the potential energy is going to be converted into kinetic energy, but there's 2 kinds, translational kinetic energy and rotational kinetic energy. So all we need to say is that the kinetic energy of the disk is going to be divided between translational and rotational, which means the translational kinetic energy of the disk less than the translational energy of the block. We actually don't need to do any more calculations. If I were to put it all together, I would say something like this. Both the block and the disk start from the same height, which means they have the same potential energy. The disk will develop both translational kinetic energy and rotational kinetic energy. The block will only develop translational kinetic energy. As the potential energies are equal, this means the translational kinetic energy of the block must be greater than the translational kinetic energy of the disk. Therefore, the velocity of the block is greater than the velocity of the disk. This means it will slide faster and take less time to get to the bottom of the ramp. So there we go. That is a mathematical routines FRQ. On my website is a PDF about the tips and tricks for FRQ questions. Click the link below to get access to that PDF. Okay, and now we're done. This question is worth 10 marks. A is worth 7 marks. That A1, the representation with the free body diagram, is with 1 mark, and the determinants and derivations together are 6 marks. Part B was 3 marks. Indicating the right thing was 1, and 2 marks for writing the right kind of way, using words for an argument.